introductory to the MATLAB Simulink. Will show you how you can run the Simulink from MATLAB. You can see here the MATLAB icon, just double click on it. And it takes a while because the program is slow. Now, mashallah, it's very quick. Now for the Simulink, as you can see, this is the Simulink icon at the middle top. You can see these are two different color, blue and red. Just double click on it. Now Windows will show up. Now what you have to choose, whatever is there. There are blank project, blank model. We normally go, or if you have some files there already on the left hand, you can choose your already Simulink program. Now we go for the blank. As you can see, this is a blank model. Double click on the blank model. Now you have a window. This is the window. That's where your Simulink file will be, the program. In the Simulink, we need to go for the Simulink itself. Now for the simulation, as you can see here, the 4 squared icons, one blue, one red. Again, we have to click it to get the library browsers. As you can see, this is a library browsers for the Simulink. By the way, you can save your file here. You can recall any already made or previous file. For the new file, then we have to go to the library. This is the library. Start. As we can see, in the library, there are so many items in here. We can choose from these. So many items. I can enlarge this library and put it aside. And here, what normally we work in our new course, we go for the continuous system. There is a discontinuous system, discrete, and other model there can be seen. But in our due course, we work on continuous, as you understand. And then what we need, our model in continuous. So we can press continuous. The other one we need the source. This is the source. It means our input to the process. Is it a step, RAM? This is a RAM. Or a pulse. Here it is a pulse. Or there is a sine wave. This is a sine. And this is the step. You can choose whatever of these. And there is whatever the output where will be your figure. The output, normally these are different display units. Normally we choose scope. Let us go first for our process itself, for the continuous system. We press continuous, we've got another model in there. As you can see, there are different icons for derivative, integrator and second order, PID controller for use closed loop, and so on. But normally, normal start, we go for the transfer function. As you can see, this is the transfer function. We can drag it and put it here in the windows. So here the transfer function is shown. As you can see, the transfer function. Now for the input, the source, we come to the source. Here it is the source. We can come for the source. The source, we can choose step. As a simple to start with, this is the step. I can drag the step and put it in here. This is the step change icon. And then for the plot, we go for this display unit. Normally we choose scope. This is the scope where our figure will be. And now we can work on those. As you can see, the transfer function, it is 1 upon s plus 1. You can change the gain. Instead of replacing 1, you can change the time constant instead of 1. Now, if double click, you can see here, the one numerator, it is the k value. The denominator, which is tau s plus 1. Here, tau, it is equal 1. That's why they put it 1 space 1. You can see they are separated by space. So if I would like to change the gain to k to, for example, 5 or 4, this is 4 for the k. For the time constant, here it is 1, 1. I change the first one to, for example, 8. Now it is 8, 1. What it means, 8 s plus 1. Just I press apply. it will show now the transfer function change from 1 upon s plus 1 to 4 upon 8 s plus 1. Say OK. That's done. For the step change, here it is the step change. The step change, this is first one, the step time. You need it where to start from 0 time or 1, 2, 0.5, whatever. Normally in perturbation, we start from 0 time. Initial value is 0. The final value, it is 1. That's the size of the step. I may put it to 2, the size of the step change. Apply. Here it won't show like the transfer function, but now the data, it is there. Now to run the program, simply we have to connect those. We're taking the end of the, the arrow from the step to the beginning of the arrow of the transfer function. Similarly, we take that icon, you can see, it is arrow. We take it to the beginning of the scoop. Now the system is connected. To run the process, just press the arrow. Here it is, the green one at the top middle. Just click it. Then you will hear a sound. That it means the process, it is okay. Anything, if there is something wrong, message you will see. You see, that's the sound blip. It means the system is okay. To see your figure, here it is. We run it. Here's the figure. We've got it. That's the figure. You can see that's the figure, but the figure is not completed to the end because the scale we choose was 10. Here it is, it was 10. I may change it. Either we change the scale on the graph or we change the scale on the Simulink model itself. Now you can see here it is 10, here it is n to the 10 as the figure. So what I can do, I can change it to 20, for example. This is 20, right? And then in this case, I have to run the system again. It changed, you can see, but it still did not reach the steady state, the figure. Again, I may change it to the 30, 30. And then, so, okay, press here and then run. Now you can see it reached to the end. So this is the figure. This is the response of first order system. The k equal 4, the time constant equal 8, the step size was 2, if you remember, was 2. Now even that's what we have. 4 times 2, it is 8. It will reach 8. So what we need, we may increase. We may increase the time to 40 to see the real. It is 40. Now run. Now it reached almost 8 because the final value will be 8. 2 the step change and 4 is the gain. Now for the figure, I can manipulate the figure. We can play with the figure. We can enlarge it a little bit, right? And then I can play with the color. For example, it is, you can see several. It can be fit. I can change the sizes. Here it is a plus. I can modify this is the zoom of the Y. And then you can see now it's changed the zoom. Even in X direction, it's changed. Or I can put it back to the normal, fit the windows, now it comes back. And then if I would like to change some other issues, I press this icon at the top corner for the configuration properties of the figure. Just press it. You can go for this color, the style. For the style, what we can see, you can see here the color of the curve, it is yellow. I can change it to the red. Just apply. It is red now, as you can see. Now, for the size, it can be changed. Again, the line, this is the line size. What type of line? It can be dotted or line, no line, whatever. And the size can be changed to 2. Apply. So the size, you can see the size of the curve, it is increased. Similarly, when we like to see the figure color, it is the outside the scale. This is, I can change it. You can see to the white. Apply. You can see the background of the figure is changed. Regarding the axis, there are 2 types. The axis, one inside that the grids color, here it is black. I can change it to the light gray. You can see, just apply. Light gray, or you can go to white. Regarding the axis, it is again gray. I may change it to the white. You can see now the whites for the grids. These are the picture. You can change again the, okay, I can change the axis for the configuration. Here it is pressed. This is the sample for the display. You can see there is Y, it was from -1 almost. I put it 0 as a perturbation in here. I may put it a 10 and just apply. You can see the figures change from 0 to 10. And then I can say, okay, now we'll come back to the color of the system. Let us, this is change it to the black. Let us see, apply. It's showing these the data in there. You can see you can play whatever you wish with the color of the figure. Now this is regarding the state change of the first order system. Imagine now you have a second order, two second order system in series. I have to remove those arrows and shift that aside. And then I can go to the continuous again, bring another transfer function. And this is, it can be enlarged a little bit. Maybe it has two different time constant. So double click for the K. I put it here, for example, keep it to the 0.5. 0.5, put it 0.5. And regarding the time constant, instead of 1, I may put it 0.2. You have two different time constant, apply, change, it's okay. Now to run that for the step change 2, still keep it at the same. Now connect those transfer function and the step change, the block together, reaching to the scope, the plot. Now the system is ready to be run. Still here 40, and then let us see run. You will hear the sound. This is the sound. It means the run is okay. There is no problem. To see my figure, I press double click on the scope. This is the response. Now the scale it is high. I may change it. Go there, and then go to the diagram configuration for the display. Instead of the maximum size, I put it to 4. Apply. You can see jump. It is okay. This is the response. It is a second order response.